Okay, let's talk about the TASC test. And if you're watching this video, I assume you already know what the task is, and maybe you're trying to get ready to pass it. So that's my assumption. And what we're going to focus on here is just basic geometry formulas and concepts that you definitely need to be aware of. So, kind of think of this as a basic little review on, again, I'm using the word basic because there's a lot more things about geometry you're going to need to know for the task, but this is a good start to kind of get your mind organized in terms of the geometry portion of the test. So if you're new to my videos and channel, I do a ton of math videos on various math concepts about the task, other tests, high set, GED, algebra, and geometry, etc. So if you like my teaching style, hopefully you'll consider subscribing. If you do, make sure you hit that bell notification because I'm posting videos all the time. And if you're looking for something more comprehensive to get ready for the math section of the task, I offer a task math prep course. I'll leave the link in the description of this video if you're interested in that. But with that being said, let's just talk about some basic geometry formulas and concepts that you're going to want to know for the task. So let's kind of get into it. So I kind of emphasized formulas here, okay? Because there's a lot in geometry that, a lot of concepts, a lot of different things that you can study, but you will need to apply a particular formula. So let's talk about some of the ones that you'll need to really know. Area formulas are going to be definitely, you'll probably definitely see questions on area for sure. So area is, let's just kind of think about it here. We just draw a little rectangle. And let's say these are feet here. So let's say each one of these boxes here is 1 foot by 1 foot. Okay. So what would be the area of this rectangle if each one of these boxes is 1 foot by 1 foot? Think of this as like a tile, maybe on the floor in your kitchen or something like that. Okay, these little squares. So if you can see here, you have 6 square feet. Okay. Now, the formula, okay, for a rectangle, the area of a rectangle is area equals length times the width. So the length here is what? It would be 3, and the width is 2. So the area of a rectangle is the length. In this case, it's 3. The width is 2, so it's going to be 6. Now, one of the things I want to stress when you're using any formula in math, especially geometry formulas, you need to be highly aware of the units of measure. So if we're dealing with feet, area is going to be in square units. So we're measuring in feet, so it's going to be 6 feet squared or square feet. Both of these are correct. So area formulas, I would, expect that most students out there or people are getting ready for the task should know so many of these basic formulas by heart. So area equals length times width is the first one. Okay, real basic geometry formula. Let's move on to some other area formulas that you definitely want to know. So let's talk about the area of a triangle. So that's area equals 1/2 base times the height. So let me draw a little triangle here, sketch it out. So here's a triangle. Now here's a deal, right? Like you're looking at the triangle, like, okay, which one's the base and which one's the height? Is it like this the base, this is the height? Well, it depends on how this triangle is configured. Okay, so let me draw a little blue thing here, and this is going to represent, like, let's say like a tabletop. Okay, let's say I have this triangle and it's sitting on a table here. Okay, now if this is sitting on this table, the base, okay, you could think of the base as this, okay, it's sitting nice and flat. So if I'd say, hey, what's the height of this triangle? Okay, you would be, well, it's kind of like this tall, right? It's this tall, and you would be correct. So if this is the base, if you're looking at the triangle in this manner, this would be the base, and then this right here would be the height, okay? And the height is always perpendicular to the base, just like that. Okay, now, let's go ahead and proceed on with this example. It's pretty straightforward. Let's say the base here is 10, and let's say the height is 5. Okay, let's use centimeters this time. So what would be the area of this triangle? So area equals 1/2. The base is 10, and the height is 5. We can always put in the units of measure after we're done with our calculations. So it's going to be 1/2. 10 times 5 is 50. Okay, so 1/2 of 50 is 25. Again, we're talking about area. Area is always in units squared. So we're dealing with centimeters, so this is going to be centimeters squared. Okay. Now, you should just know this by memory. Now, on the task, I'm actually not quite sure. I believe on the test itself, they do have, but like many tests like the SAT, ACT, GED, I'm pretty certain, I definitely know for like the SAT and ACT, on the top of the page or where the questions are at, in some of these sections, they'll have a list of formulas. Okay, so you'll want to double check on that, just to see if these formulas are given to you. I'm actually not quite sure. I probably should actually follow up and check. But some of these formulas you should just know by heart, by memory. Okay, that's why I'm stressing basic geometry formulas. So even if they give the formulas to you, you should just know them. Okay, these ones here that I'm talking about. Let's go back to this this triangle now. Let's take the same triangle. All right. Let me see if I can draw this out pretty good. Okay, so I think the triangle was kind of like this way. So I could kind of like tilt the triangle so it looks like this, okay? So if you remember, this was the base last time, okay? If I just flip it, now I kind of set it this way on the table, this now would be considered the base, right? This here. So if this is the base, I ask, well, how high is this triangle if it's sitting this way on the table? You would say, oh, it's this high, and you would be correct. Again, it's going to be perpendicular to the base, but this time the base kind of extends out. All right, so this is the height here, right? And you could just do the same calculation. You'll still end up, you'll have different base and height measurements, but irrespective of that, you'll still end up with the same area, okay, depending on how it's calculated. So again, basic formulas, and obviously need to know how to apply these basic formulas. All right, let's move on. Another one for sure. Area equals length times width. This applies for rectangles and also squares. Squares is side times side, but a square is a type of rectangle or quadrilateral. So this covers our squares and rectangles. This covers all triangles. So you got triangles, you got squares, you got rectangles. Another basic figure in geometry is circles. So this is pi r squared. Definitely want to know this. So here is a circle. And you're going to want to know how, this is not the best circle, but I kind of sketched out there. You want to know how to find the area of a circle. So the width of a circle, we don't use that term width, but it's how wide a circle is called the diameter, okay? That diameter. And it passes through the center of a circle. So you can, if you think about like how wide a circle is, you can measure it this way, you can measure it any number of different ways, right? But it's going to pass through the center of the circle, okay? Now, the center out to the edge of the circle, all right, is called the radius. It happens to be 1/2 of the diameter. Okay, so if the diameter is 10, the radius is 5, for example. So to find the area of a circle, the formula is pi r squared, pi r squared. So what is this pi? Let me actually write the formula up here. Area equals pi r squared. So pi is an extremely important number in mathematics, especially geometry. It's roughly, okay, it's approximately equal to the decimal 3.14. Not exactly, this is an estimation, okay? Pi actually goes on and on and on. So it's approximately, when you have, here, let me write this out here just as a kind of a FY. Here's the symbol for pi. It's just this is actually a Greek symbol. Okay, so it looks like this basically. And if I say that if I use this equal sign where my bars here are equal to 3.14, this is actually mathematically incorrect. Pi is not 100% totally equal to 3.14. The way I would write this is pi is approximately. So if you see two squiggly lines like this, it's like the equal sign, but they're kind of a little squiggly. That means approximately equal to 3.14. So that's just a good something to kind of be familiar with. It's just good to know. So this right here is not true because pi is not 100% perfectly equal to 3.14, but it's approximately equal to 3.14. Okay, so when you use the decimal 3.14, you're just going to get a very close estimation of the actual answer. Okay, so in mathematics, more advanced math, we actually like to just sometimes we just express our answer by just leaving the pi symbol in there because it kind of represents the entire value of that number. But I don't want to go digress too far off on a tangent. Just know that you can use 3.14. You can also use the fraction 22/7. Okay, these are good, very good approximations. And if you look in your calculator, most scientific calculators, you'll be able to pull up a value that's even more precise than these. But you can use either one of these here. So let's suppose I wanted to go ahead and find the area of a circle that the diameter, let's say, was 10. Okay. So if the diameter is 10, the radius is what? 5. So sometimes they'll give you the radius or they'll give you the diameter. Again, let's say millimeters here. Okay, so how do I find the area? Very simple. So it's going to be area equals pi. The radius, in this case, is 5 squared. Okay, now when you do this, remember with the order of operations, you have to square the number first before you multiply. You got to do this square part. So hopefully you know how to do that. They just multiply that number by itself. So 5 squared means 5 times 5. So this would be pi times 25. Now here, I'm not going to actually do it. I'm not going to take my calculator out. But you can go ahead and if you wanted to get a decimal approximation, you can just take 3.14 and multiply it by 25. Okay? Or you can just simply take 25 and it's always customary to put the pi at the end of it, not in the front. You can just say this is your exact answer. Okay, and again, if you didn't have a calculator, you wanted to work with fractions, you can use 22/7 as well. So it all depends on how let's say your answer choices are given to you. Because if your answer choices are all in pi, then you have to express the answer with the pi symbol. If it's a decimal, then you want to go and use 3.14 to calculate that out. Okay, but this is definitely, and by the way, here I'm forgetting one thing. Let's go ahead and add it in. What am I forgetting? Little pop quiz. Because this is millimeters and I'm finding the area, it's what? Millimeters squared, units of measure, right? So again, always good to double check your work. So for sure, area formulas, squares, rectangles, triangles of all sorts, and circles are hugely important. Now, let's suppose, let me go back to the circle scenario. Now, once you know how to find the area of a circle, then you can find the area of any kind of segment or portion of a circle. So let's say I had something like this, and let's see here. If I said find the area of this sector of the circle, okay? And it had a little like perpendicular thing, and this went through the center, and this was 5 right there, 5 millimeters, okay? So if I wanted to find the area of that portion of the circle, I would want to find the area of 1/4 of the circle. You see that? Because there's 4 of these sectors here. So you would find the area of the entire circle. So area equals pi r squared. Again, this is the radius. So remember, this turned out to be 25 pi, right? We're just doing the previous millimeters squared. But if I wanted to find out the area of just this portion of it, I would multiply this by 1/4 or take 1/4 of that or divide this by 4. Okay, and I would get the area of that. So look out for those type of questions. That's pretty common as well. Again, this is basic, just real basic geometry kind of stuff. All right, now I'm going to switch away real quick. I don't want to make this video too long. So that's area. All right, the next thing you want to be familiar with is volume. Okay, so the volume is different, all right? And I'm going to just do a couple different examples of volume. Now, by the way, too, let's just go to area. So let me go back to area real quick before we jump into volume, okay? So we covered rectangles, we covered triangles, and there's circles. But there's other type of basic figures that now this is pretty basic for area. So I'm trying to think of something right here. Well, you can have parallelograms, all right, which is pretty easy. This is the same as a rectangle, okay, as well. If you take my course here, I go over all of these particular formulas and how to use them. But again, you just need to be familiar with them. I'm not going to cover all of them because there's just too many. But volume now, let's take our square, okay? So volume is like where things are three-dimensional, okay? So this would be a cube, for example. So think of a volume of how much, let's say I had a cube here, like how much water I can put inside. Okay, whether it's a cubic type of thing or like a shoebox scenario, that would be like a rectangle, right? So this would be like a box, all right? Same idea. It's like how much water can you fill in the box. This is the concept of volume. Now, if I'm dealing with a circle, you can think of it like a cylinder, all right? Yeah, I'm kind of using my artistic skills here. So cylinder, how much water can you put like in a can, like a can of soup, that type of thing. So this is volume. So there's different applications for this. But the one thing you want to know about volume, let me actually finish up with area. Area, remember, was units squared. The one thing about volume, it's going to be units cubed this time. All right, so let's take a look at a couple quick examples, some formulas that I'm just going to highlight something else. Again, this is not going to be totally inclusive. It's just to get you thinking like, hey, do you know these minimal type of things for this test? And there's more beyond what I'm going to be able to cover in this video. But anyways, it's just kind of a good self-check to know. So let's take a look at a cube. Very simple. This applies for a cube or a rectangle. All right, so here's my cube. So let's say this is like 5 this way, okay, whatever units you want to use, 5 this way and 5 this way. All you do is just multiply all the units together. So 5 times 5 times 5 will give us 125, right? So yes, it'd give us 125. And if this was millimeters, it would be millimeters cubed, okay? So pretty straightforward stuff. So the volume of a cube would be sides cubed. All right, so that's the volume of a cube, sides cubed. If we're talking about a box, it's going to be the length times the width times the height, which is basically what we're doing here. But the sides of a cube are all the same dimension. Okay, they're all the same number. So these are pretty much kind of equivalent, but this would be a box scenario. So let's take a look at a cylinder real quick. So because we could find the area of a circle, this is pretty straightforward. All right. Ooh, that's a terrible cylinder. I could draw a little bit better than that. Let's see here. This is a little bit better, I think. All right, here's my can of soup. Actually, that's not so good, but I think we get the idea. Anyways, so let's say we have the radius right here. Okay, so there's the radius of this circle. So if I wanted to find the volume of this cylinder, this is the height. Okay, the formula, that's the radius here. The formula is pi r squared times the height. Very straightforward. So we're going to find the area of this circle up here and then just multiply it by the height. So let's say the area or the radius again is 5. So this would be pi times 5 squared, and let's say the height is 10, okay, on this. So we're going to multiply this by 10. That's our height. Okay, this would be the entire volume. Let me actually kind of make this a little bit better here. That's our radius, and this will be our volume. So this would be volume equals, remember you got to do the powers first. This is going to be pi times 25 times 10. So the volume will be equal to 25 times 10 is 250. So 250 times pi, and then whatever units these are, let's say this is feet, it would be feet cubed. Okay, so volume of cylinder, that's let's see here, pi r squared times the height. So definitely a basic formula concept that you want to know. Now, volume gets very interesting because you get into all kinds of different things here. All right, so that's a cylinder. Let's take a look at some other things you may have to find out. Okay, so what about like something like a basketball? Okay, that would be called a sphere. All right, like a tennis ball or basketball, or soccer ball, whatever type of ball, the volume of it, that's a sphere. Now let's take our triangle. We have a triangle, right? And what if we do this type of deal? We make it 3D. Now we have a pyramid. So you can find the volume of pyramids, spheres, and these have additional formulas. So this is stuff I'm not going to cover here, but just to show you, these are basic geometric formulas that you need to know how to apply. But the one thing is holds true. Anytime you're looking for volume, all right, of these basic figures, it's going to be units cubed versus area, and surface area will be units squared. All right, so there's other formulas for those. You can either check out my full course or maybe some of my other videos or look them up on your own. But again, things that you need to be familiar with for the task for sure. Now, the last concept that I would definitely make sure you're familiar with, basic geometry formulas, is perimeter. Okay, so the idea of perimeter is the distance around something. So if this is a rectangle and this is 10 and this is 5, and I ask you to find the perimeter of this rectangle, that means I want you to add up all the entire distance around this rectangle. So here, this would be 10, right? And I go 5 this way, then I got to go another 10 this way, right? And I go 5 down here. So how much is that? 10 and 10 is 20, and then 5 and 5 is another 10, so this would be 30, right? And if this is in inches, all these are in inches, that would be 30 inches. Okay, so perimeter is the idea of walking around or getting the measurements around anything. So the perimeter of any object, whether it be a rectangle, and you could see this too. You can see some crazy type of objects like it might look like something like this. As long as they give you the measurements, so this is 10, this is 5, this is 3, this is 4, this is 2, and this is another 4. You can just add up all the sides of any figure, and you'll get the perimeter. Okay, so that's a concept you definitely want to know, perimeter. Now, lastly, and there is no particular formula other than that, other than just adding up the sides, but there is a formula for the perimeter of a circle. Okay, and the perimeter of the circle is, we don't really refer to it as the perimeter. I don't say don't go find the perimeter of the circle. That's referred to as a circumference. Okay, so the circumference of a circle is equal to, 2 pi r. Okay, so 2 times pi times r, it's the same thing. Remember, 2 times the radius is the diameter, so the circumference is also equal to the diameter times pi. Either one of those formulas will work, and the circumference of a circle is effectively you can think of it as the perimeter of a circle. So again, if I have a radius of 5, let's say 5 millimeters, what would be the distance around the circle, which is conceptually like the perimeter, okay, but we call it the circumference. So it would be 2 times pi. Let me write this out a little bit better. 2 times pi times the radius of 5. So 5 times 2 is 10, so the circumference is equal to 10 times pi, okay? And of course, I could just go in and replace that pi with a 3.14, so that'd be like 31 and change, whatever it is. But one thing to know, this is my final answer, and if this is in millimeters, this would be in millimeters. The circumference is distance, so it's going to be in the same units of measure, right? So it's just going to be in units because we're talking about distance, not units squared, not units cubed. So this is the perimeter, what we call the circumference. Okay, you want to know that as well. 2 pi r, or the circumference is diameter times pi. You see it both, and you'd see the circumference given in both of these particular formulas. They're equivalent. Okay, so we'll just cut a basic overview, and this video probably went a little bit longer than I wanted to, but you can see it. These are just some of the basic formulas. You need to know a lot. again, the task is nothing to play with. If you're trying to pass a task, you need to know a considerable amount of algebra and geometry. So the right thing to do is to start studying, right? And if you really need help and you need a good organized course to help you out with it, then I would highly recommend my task math prep course. But let's go ahead and call this video a wrap. Again, if you like my teaching style, hopefully you'll subscribe, hit that bell notification. You want to take my full course on the task math section. I'll leave a link in the description. If you enjoyed the video, if you like my teaching style, definitely appreciate a thumbs up and leave me some feedback. Definitely appreciate it. I get a lot of comments, but it's one of the ways that gives me feedback on how I'm doing and gives me ideas on what I can do to better help you, especially if there's questions that come up over and over again. But I am posting videos all the time, all with the effort or motivation to help you out. Okay, whether you take my courses or not, if you're watching my videos, then I know that you're getting something out of them. But with that being said, I definitely appreciate your time and have a great day.